Today we're breaking down the polar vortex, everything it is and everything it equally isn't. This is a term that's really been picked up by the media in the last decade, but there is a lot of science behind it. We're recording this in January of 2025. It's relevant now because we have a huge Arctic blast coming, and I feel like whenever we have cold air, you hear a lot more about this term, but this video will be relevant whenever. We're just getting into the science and explaining, again, what it is and some things that you probably don't know about, and trying to dispel some of the media misusage of the term. So let's jump into our forecast and break down everything you need to know about the polar vortex. The first thing we have to talk about, and you're not going to get this from the media. In fact, there's a really big disconnect between the science and meteorology community and the media on this point, and it's that there are actually two polar vortexes, although the main one is not the one that the media often refers to. It's this stratospheric polar vortex you can see outlined in blue. And as the name would suggest, this is really high up in the stratosphere. We're talking, on the order of 100,000 feet high. And it does have an influence on our weather. But the one that has the greatest influence on our weather is the tropospheric polar vortex, outlined in red there. That's what brings us our real cold air. It's the stratospheric vortex that can sometimes influence it, though, which works as sort of a chain reaction in bringing the cold air to us. But I want to make sure that difference is well documented here. The stratospheric polar vortex, that is the quote-unquote real polar vortex. The tropospheric polar vortex, that's the one that we know in the media and we know to bring our impactful weather. It certainly has a much bigger influence on us than the stratospheric one does. We can actually see the polar vortex in the stratosphere right here, and what you're looking at are wind speeds around the pole. I'll circle some areas you may be more familiar with. Here is the North America. This is Asia out here, and if we keep on going, we're circling Europe out here. So we're looking at the polar region, the North Pole being right around the middle of your screen, somewhere in here. And this vortex, of course, is circling the pole. And that's important because whenever you have this closed, strong circulation in the stratosphere, that tells us the polar vortex up there is strong. And it's less likely to have a big influence on the vortex closer to the ground. When this thing, though, gets a little bent out of shape, and I will say, it is a little stretched out. It's a bit weaker. Some experts right now believe it may be partially contributing to colder than average weather in the US. But when this thing really gets knocked off its kilter, we see the vortex closer to the ground get really wavy. And we'll talk about that in a moment. But what I want to say, first of all, is that this is nothing unusual. This is a normal seasonal circulation on the Earth. It forms later in the fall, it dissipates later in the spring in the northern hemisphere, and I can actually show you the southern hemisphere where it is currently the warm season, of course. And what you'll see is that there's no vortex, and that's completely normal. It's a seasonal vortex, and it comes and goes with the weather in the Arctic in the fall and spring. This is also something that you may have heard, a sudden stratospheric warming event. We talk about those sometimes when the polar vortex, again, gets weakened. That causes that polar vortex near the ground to get weaker as well. So there's a correlation. When this weakens, it is more likely the one at the ground will weaken. However, we don't need this to weaken for the one at the ground too. So they're somewhat independent here. This is our vortex that you're more used to in the troposphere here. What you're seeing is flow across the polar region. And if I recenter our Arctic there, now we're looking basically straight down to the Earth. You can get a rough idea of where this circulation is. Again, this is just sort of a rough drawing of the outline of the current polar vortex. So that's where our cold air is bottled up closer to the ground. And what we're seeing is this become a little bit more wavy now, at least in the US. And when you get those waves to break off, you have cold air that spills straight down into the United States. So this is a big piece of our weather. Not as much the one in the stratosphere, but this one, which can be influenced by the one in the stratosphere. Now you can see more clearly where it is, and if I show you the outline again here, you can kind of see outlined pretty well by the light blue colors. That basically tells you where the cold air is bottled up and where it isn't. And right along the white line I just drew, that's more or less the jet stream going around. You can see it's kind of wavy. It's reasonably put together, but there is certainly some kinks in it. And as this becomes more wavy, we're more likely to see colder air. What we're really looking for our weather to get just bitterly cold are these pink colors. These are individual lobes in the polar vortex closer to the ground, the tropospheric polar vortex we're going to refer to it as. And in the tropospheric polar vortex, whenever those lobes get closer, that's when your temperatures really drop. That's when a really cold core of air begins to drop in. So if I put this into motion, you're going to see this begin to spin a little bit, and you're going to see one of those lobes begin to dive down to the US. You're also going to see another one move into northeastern Asia. And when the tropospheric polar vortex splits off like that, that's when you have those real cold bursts, which we are going to see. And as we head into this upcoming weekend and next week, this will be around the 18th to 24th, really. That's where you see pretty clearly here, we have a lobe that is completely broken off, branched into the US. This is a lot wavier now. You can see there really isn't as much of that smooth look to it. This can do it, become wavy, do its thing all on its own without the stratospheric polar vortex becoming weaker or wavy. But there may be at least a little bit of a relationship here. Certainly if that stratospheric polar vortex did become wavy, you would expect this to react in a similar way. This time, it's more working on its own with maybe a slight influence. But what you're looking at is that lobe of the polar vortex diving into North America. So that's when it really gets cold here. That's why people are all of a sudden going to start saying the polar vortex is back. I want to make clear, though, is that this is a very normal circulation as well. There's really nothing extreme about this polar vortex, the one in the tropospheric polar vortex. It's here all year round. Okay, it's just in the wintertime when you get one of those cores to dive into the US, it becomes a big deal because we get really cold. But that's really all there is to it. So of course in science we have a measure for basically everything, and one of the measures for how wavy the tropospheric polar vortex is the Arctic oscillation. And when this becomes negative, when it drops below this flat line here, that means that the tropospheric polar vortex is showing that wavier shape, and it's more likely to get deep cold farther south. So if we take a look at what we're going to see here, we're looking at basically this spot right there. You can see this does become negative slightly as we get into this cold period ahead. So the tropospheric polar vortex is becoming more wavy. Though I'll say this is a global indicator, and while we may get some cold weather, the rest of the polar vortex can be, decently put together. So it's not a perfect one-to-one correlation with the United States. It's a big picture thing. That said, we certainly are going to see a little bit more waviness. The jet stream, that polar jet, when it weakens, that allows this tropospheric polar vortex to become more wavy and the Arctic oscillation to become more negative. So it's this little negative area here that'll be part of our cold spell, but certainly there isn't a strong indicator that we're going to see persistent waves of cold here. It looks like it'll be a one hit, and then this thing becomes a bit more positive. But that does have big impacts on the surface, and we can take a look at just how cold it's going to get this time around. And temperatures certainly are going to be well below zero, as they often are when you hear a polar vortex in the media and when you see it play out like this. So here we can look at our temperatures for the week ahead, and one of the things you're going to see are those purple colors really beginning to show up. Those are temperatures in at least the single digits. When they get to the dark purple color, that means they're below zero. And we'll move this forward. This is Wednesday, the upcoming Thursday, going into Friday. And you're seeing that deep cold begin to spill across the U.S. heading into Saturday and especially on Sunday. And what you're seeing are temperatures in the single digits diving down as far south as potentially North Texas. And sub-zero temperatures diving down pretty far south into places like Nebraska, Iowa, Wisconsin, Minnesota. Places like that are often cold, but they'll be especially cold here. If we move this forward into Monday morning, that's when some of the coldest weather is going to be here. That's when that core of the polar vortex begins to move into southern Canada, and you can actually see out here temperatures are going to be in the 20s and 30s below zero where that core is. In fact, we're likely to be in the 20s below zero in portions of the north central U.S. here too. Now this thing continues to shift around as we head into Tuesday. Like I said, it's not one that's going to be as long lasting, but once again, I mean, even on your Tuesday morning, you're looking at low temperatures below zero now, moving into the northeast for much of the Midwest. This is all the way as far south as Missouri, Kansas, even New Mexico, and some of those mountainous areas could be below zero. And you're actually looking at 20s even into places like northern Mexico. Even Houston is not out of the woods for the potential of a temperature in the 20s, at least the Houston area, perhaps not in the coastline, but right down to the Gulf Coast. That's where those blue colors are indicating temperatures 32 or colder. We continue to move this forward, and we will see a pretty quick recovery as that lobe begins to retreat back into the vortex, farther into Canada. But certainly it leaves its mark, and that cold weather is going to be felt across a huge chunk of the country. Very anomalous cold. And the other thing that we can get that's anomalous beyond cold is snow as well. And during these polar vortex events, you're able to generate cyclones, storm systems, often on the leading edge and on the eastern edge of these lobes. And for that reason, we're going to see the potential for storm development much farther south than usual. I mentioned anomalous cold. You also typically get some kind of snowfall, or at least some kind of potential winter event much farther south than normal, especially as these lobes begin to enter the United States. So this is not to be taken as gospel, but it gives you an idea of the potential for snowfall across the U.S. while this polar vortex is in play here. And what we've been seeing pretty consistently is the potential for snow across states like Texas, Louisiana, Mississippi, Alabama, Georgia, even the Carolinas. To get something as far south as some of the states I just mentioned there, again, Texas through the deep south, obviously that's unusual. But with a polar vortex event like this, it can happen. The other thing that really stands out is when you get these really cold lobes of air, it's often very dry as well. You actually have this gigantic hole where there is not expected to be much snow, and that's exactly where the coldest weather is going to be. So that coldest weather often does not coincide with snowy conditions. So we'll leave it there with that. Hopefully that helped to clear some things up. Again, the biggest things here, I actually wrote them down in my notes, so I'll reiterate. There's two vortexes. You have the real polar vortex, is that one in the stratosphere. It can sometimes influence the one in the troposphere when it weakens. The one the media typically covers is our main player, the tropospheric polar vortex. That's what really impacts our weather. The one in the stratosphere plays a secondary role. And both of these vortexes are completely normal features. That said, it does coincide with extreme events, and these extreme events are very exciting to track for meteorologists like myself. So when you hear about it, it's true. It gets very cold. It can often snow farther south, but in and of itself, the tropospheric polar vortex and the polar vortex in the stratosphere are nothing unusual. And hopefully this helped to break them down. And if you have any questions, if I didn't explain anything that well, just drop them in the comments. I'll answer your questions, and we'll get back to our normal forecast videos tomorrow. So stay tuned. We'll be tracking this snow, this cold, and a lot more right here. And we'll see you next time.